I was thinking when we were having that little conversation with Neil and Ben, we were talking about stuff that is missing, like the moon rocks in particular. I mean, it's easy to just put a label on it and say it's a moon rock, but where are the ones that they collected? I mean, everything that they did should be public information, like it's a government operation. So all of the stuff that they had collected on all of the locations that they went to, they should have those as samples as well. And when we were talking about the photographs and the cameras and everything else, there are officially in the articles, when they were in their training, they were sequestered. Like Apollo, I think 12 was sequestered 16 months. They were sequestered the longest. So how could they take the cameras home and practice with them, with their families, if they're sequestered, right? A little conflict of interest there, right?
The ones they were using to practice at home were regular Hasselblad cameras that were supplied to NASA before the Apollo missions. The actual lunar Hasselblad cameras were supplied later without a viewfinder. So they wouldn't have been very good for practicing with.
No, it wouldn't serve them anything other than they'd learn the features of the camera, which wouldn't take very long. But then, where are all of those magazines?
Yeah, good question. Where are they?
All of their practice sessions.
Yep.
They had the cameras as listed. It's in the FINI file. They had the cameras, extra magazines, extra batteries. They had multiple rovers available for them to work with when they were doing that, extra backpacks. Where are their practice suits? Where are the practice PLSSs? Because they were not walking around to practice on Earth with a 180-pound suit and backpack on.
Yep, they weren't.
So where are those suits?
Good question.
I think they're on display.
What, in museums?
Exactly. And I think the photographs are part of the official record. And I mean, we didn't see the magazines put together for 30 years. For the 30th anniversary, that's when they were uploaded online. They had all of that time to put together any number of magazines and put it just down as one.
Yep. Hence Neil Armstrong's cryptic comment about removing one of Truth's protective layers. That was the 25th anniversary he did that, before they all got uploaded onto online.
And that's why you see in the photographs a mock-up of the LEM, because that's not a real LEM. That's not a functioning anything. That's why Buzz Aldrin can be in the door frame, because there's actually no interior inside that craft.
Yeah.
And it wouldn't have had an engine or anything else there. And that's why the bell housing is just a piece of aluminum. It's not a real bell housing. You can see that. You can see that it's just curled up around the edge, and you can see the seams down on it. Okay, that's not a functional bell housing for an engine. The engine has the cooling coils and everything else in it. That's not in that photograph. That's just a mock-up. Where are all of the photographs from their practice?
Well, let's hear from some of these Apollo proponents who support Apollo, support NASA, and think that we're all completely wrong. Answer those questions. We only ever ask questions. So you have the knowledge, apparently. You have the knowledge to support NASA. So answer our questions. Stop picking holes in a few silly arguments and answer some decent questions. That's all we ask. Where are those photographs? Where are the reels of film taken by the astronauts during their practice sessions?
And the DAC cameras would be functional, recording it. The television cameras would be functional, which they would have recorded on the 16mm film. All the practices in the simulators where they were filming them, where's all that?
Yeah, exactly. Where is it?
They were practicing the docking, undocking, and that's all photographed.
Yeah.
Where's all of that?
Any pilot practicing in an aircraft simulator is filmed so you can be debriefed later. The same thing would apply to Apollo. The astronauts were filmed when they were doing everything.
All of those things are missing, and it should all be part of the record.
Exactly.
Okay. And like I said, the biggest thing is, where are the rocks that they collected when they were out on those different surveys? You know, they were in Hawaii, 4 or 5 different states. They went to Antarctica and they came to Canada to a couple of mines there. I'd like to see the rocks that they collected for there and compare them with what they claim are moon rocks, because that would tell you a lot.
It would tell you a great deal that they never went to the moon to collect them.
Right, because they don't have those rocks, because those are the rocks they claim that are on display.
And the idea that they can claim, which they do, NASA claims 382 kilos of moon rock were brought back on the 6 missions they alleged collected them. So where are they? Because 382 kilos is a lot of weight. And as Randy has continually pointed out, and it's an obvious thing to point out, when you load any craft, whether it's a spacecraft or an aircraft, you have to know the weight distribution, otherwise the thing goes out of control. If you're coming back with the same weight as an astronaut, additional to what you left with, that's what Apollo 17 claims to have done. Where are the calculations? How is it calculated? How is the weight distributed within the spacecraft? That's quite critical. No, we're not told any of that. In fact, we have to believe what we're told by NASA.
Now we go back to lifting off of the moon again. You're not on level ground. The LEM, when it landed, the legs would not be evenly placed. Like you see them in all the photographs, the legs are all the same length except for Apollo 15, where they had to add one longer. It's actually longer than the original length because it's sitting in that little bit of a crater. You would have to land perfectly because each of the legs crush down and they're not spring-loaded to come back. They're just aluminum honeycomb cylinders that crush down. And of course, they've updated it. They started out with 2 of them in there to crush down, and then they've made it 3. And they put little bushings in them as well, so that they don't cold weld themselves together while they're in flight. They've added a few things with, like, every time they update the legs, every leg would have to land equal amount of pressure coming onto it on an uneven surface, which is impossible. Each leg would fully compress at 3/4 of a G on impact. And even if you just set it down gently with no G-forces on the landing, it's still going to compress 10 inches on each leg. And you don't see that in the photographs. You're not seeing that there. So you add that, the blast crater, because there's no engine, because Buzz Aldrin's standing there because there's no console to run the engine. You know, I mean, those are part of what they were doing in practice.
Yeah, exactly. Good point.
So the suits you see them wearing there are their practice suits, because they couldn't possibly do that on Earth coming down that ladder with 180 pounds on them.
Yeah, and you'd hear them, because if they were wearing their suits when they landed the craft, you would not hear anything except through the microphones. If they weren't wearing the suit, you would hear everything, because it is an atmosphere through which sound travels. So if sound didn't travel through the atmosphere because they were wearing their suits, explain, NASA proponents, how they controlled the craft wearing heavy-duty gardening gloves, hardly able to see much out of their helmet. They have to wear a helmet. You can't just wear half a spacesuit. You've got to wear the whole thing. The helmet, the gloves, the boots, you've got to wear everything. So if you don't hear external noise, you have to assume, because it's physics, this isn't any sort of conspiracy. You have to assume, if you can't hear any external noise, that they're wearing their spacesuits when they landed the craft. And when you got a 10,000-pound thrust rocket, just a few feet below you, attached to the descent module, it would vibrate through the whole craft. But you don't hear any of that. You hear Aldrin reading out figures, 2 down, 2.5, whatever. You don't hear Armstrong do very much.
Well, the craft still was pressurized. They would have had their suits on in case they had a leak in the craft when it landed, right? In case something split.
Fell over or something. Yeah.
But the craft was pressurized, so any vibration coming up through, any sound coming through the craft itself would transfer inside. And they were just talking normally all the time. And then every time you hit a thruster, you're going to be jolted around because you're standing just with tethers on your waist and you're trying to operate a joystick at the same time. And Neil Armstrong did test that, and he couldn't operate the simulator standing every time it moved. your hand's going to control. You have to be sitting down to
Right.
be able to operate that thing. And that's why the flying bedstead, they were sitting. All of those things just go into the fact that they actually weren't there, because those type of things would have been sorted out long before they got there.
Yeah. And you don't see any pilot of a commercial aircraft, or a military aircraft for that matter, standing up to fly it. He sits down for that reason. He'd be thrown around.
Yeah, and taking off, they did set the fuel tanks up so that they were evenly dispersed weight-wise as they were being consumed.
Yep, they did.
But when you add a bunch of rocks in there, even when they're shifting around inside the craft on takeoff, because you only got little tiny retro rockets to adjust, they don't have a whole lot of thrust. There's no gimbal when they're taking off. There's no gimbal on that engine. It's just a straight thrust. And if you get jostled over to the side, you're going to affect the weight of the craft. And then when you try and adjust it, you're going to get thrown the other direction with the retros on there. And if you didn't have those rocks perfectly balanced in the center taking off, you couldn't just set them off on the side. You'd have to adjust for that.
Yeah. You'd have to make sure the balance was correct.
And then the timing. You have the CSM is orbiting. The timing that they had in the very short time that it's going to come into audio range for them to talk to the craft and decide to take off. And then they have to know how much they actually weigh and how much thrust there's going to be. And this is an engine that has never been fired before and built. They know it's 3,500 pounds for the ascent module, right? But what if it's not? What if they built it and it's off by 100 foot-pounds or whatever a thrust? It's not accurate.
Well, they
And
had,
built.
yeah.
Then they got to know how much they weigh and how long it's going to take them to get up there to connect. And every time, because the moon is rotating a little bit as well, every time that CSM orbits, it's not going to be in the same spot. That's got to be calculated out, and you only got a couple of minutes before you launch to connect with them. And then they go out of audio range again for the next orbit.
If the craft you're trying to connect with, the command module orbiting the moon, is flying at 6,000 miles an hour, you haven't got a big window in which to launch. You've got to get it spot on. Otherwise, you're not going to catch up, because it's going to go so far ahead of you.
What, they had 7 minutes and change of fuel that it took off to get up to 6,000 miles an hour off the surface. They're in audio range for 22 minutes per rotation. It's going around every hour.
Yep.
They had audio contact with the CSM for 22 minutes. That means that there's 11 minutes. It's going to be directly overhead. So you got 5 minutes when you start talking to them, whether it's a go or no go to lift off, to connect.
You do, but we didn't hear any of that. There was no discussion about when to launch. It was just, oh, let's go.
They'd be calling back to NASA, asking the guys with their slide rules, that room full of 40 guys with slide rules, to do the calculations.
Yeah, the trouble is it takes 2.5 seconds for the question to go to Houston and for the answer to come back. It'd be too late.
Well, and then how long is it going to take for the guys with the slide rule to work out? They were all conferring on the calculations. And that's mentioned when they were doing adjustments on their flight, so-called. They're calling back with numbers from the sextant coming back, and the guys with the slide rules are doing the calculations, not a computer, to confirm those numbers.
Exactly.
And they'd have to do exactly the same thing on that launch. Once they get up there, they're out of fuel.
Well, I think that's what Xavier Pascal, in his quite detailed articles on the Owlis website, demonstrated, that they didn't have enough fuel. They didn't do anything accurately enough. The computers weren't up to the job. And yet, miraculously, 6 missions landed, took off, connected with the command module, flew back to Earth, big heroes. That was the story NASA wanted. Anything outside that is not even discussed. And that's what the problem we've got now with the Apollo proponents, who won't come on and discuss it with us face to face.
And who replaced the seals? Don't forget, they already did a docking, undocking, to turn around and dock with the craft to get there. And now we're working with one-time use seals. Just like Bill Demos is going to tell you, right? They're copper seals. You're in a hard vacuum. You're not using rubber.
No, you're not.
And then when you're docking, you're going to have to be super gentle to get onto there, because if you bang that seal, just even a little impact, you're going to ruin the seal. And they got to put these two crafts back together again. And they did that every time, but nobody got out and replaced the seal.
No.
That should be part of the program. They landed on the moon, they open up the top hatch, and then replace the seal.
Yeah, they should have done.
They went up and took photographs up there, but they never replaced the seal.
And there's no record of any seals, any additional seals being carried in the manifest.
Nope.
None at all. So they hadn't even thought of that.
And that's the very critical part of the entire flight.
Yeah, it's life and death. But if that seal doesn't work, you're toast.
And they should have practiced that.
Of course they should.
And that's why we should see the video of them doing their docking, undocking procedure, probably done at Menlo Ham, at the hangar there. That should be all part of the records and the recordings that are in the McDonald's there.
It should be.
All of that should be there, and see how many times they failed, how many times they were successful, how many times in the simulator they bumped in too hard and damaged the seals. All of that should be recorded.
But it doesn't seem to have been recorded. It doesn't seem to be available to anybody to see.
No. And all of the technical stuff that's not in the transcript, all of the conversations that they should be having, is just not there. These guys get into the spacecraft, they're going to take off. They're going to be talking to Houston. They're going to need an update on the actual orbital speed of the CSM and the tracking of it. They're going to need to know exactly where they are. They're going to have to refer back to the exact attitude that they are sitting on. At least estimate the weight of the rocks that they brought in, and then go through an entire countdown check. They got to be right to the second to take off. And the adjustments that they're going to have to make with the retros to line up to meet that thing all have to be there. They're not doing that. They're putting in a cassette tape and playing Off Into the Wild Blue Yonder.
Yeah, exactly.
Right?
More emphasis on the songs that they played. Apollo 13, they're playing Aquarius. I mean, what are they playing at? Because any time that you fly on a commercial jet, the pilot goes through quite a long checklist before he can take off. And he has to confirm it with his co-pilot. Well, on Apollo, you had a pilot and a co-pilot, otherwise known as the lunar module pilot and the commander, in the case of Apollo 11. But there were no checklists that we've ever heard anybody reading through.
You want to know that the door is sealed when you got back inside. After you pressurize, you're going to make sure that the pressure is holding. That should be part of the conversation.
Yeah, because if the pressure isn't holding, you're going to run out of oxygen very soon. And it's all leaking out.
And those door seals are covered in dust. They're not going to seal. You know there's going to be a certain amount of, I don't care if it's a slow leak or whatever, it's going to leak down. And that's going to limit the amount of time that they can actually sit there. Somebody's going to be doing an estimate saying, okay, you're losing this much pressure, you have this much oxygen to refill it and keep you there, and this is how much time you've got. All of that should be in the documentation. They should be asking how their condition are, because all of a sudden they dropped from a pressurized down to a very low pressure in their suits, back up to 5 psi. They should be suffering some kind of altitude sickness that should be discussed.
Well, of course it should, because 5 psi or even less, which is what we're told the astronaut suits were pressurized at, is the same as the air pressure at the top of Mount Everest.
Exactly. They took off at sea level to that, and within a few minutes, they had already dropped down to 5 psi. You can't just get dropped off on the top of Mount Everest and expect to survive very long. You can't even go up to Lake Titicaca in Peru and sit there and be there for the afternoon. Within a few hours, you're going to be suffering from altitude sickness. And that's only going up 12,000 feet.
Yeah, you have to acclimatize to it. You have to acclimatize the body to that lower pressure.
Right. And here they are going in a few minutes into space. By the time they cross the Kármán line, the spacecraft is going to be down to 5 psi.
Or probably less. The Kármán line, named after Theodore von Kármán, a NASA engineer who decided to identify the location that space starts. And he chose a nice round number, 100 kilometers above the Earth's surface, 62 miles. In fact, space starts at 50 miles above the Earth's surface. And you can tell that because if you put an aircraft above 50 miles, it's got no control because there's nothing for the wings and the flaps to work against.
I think that's at about 200,000 feet. They're already having that problem.
Yeah, they are.
Wings don't work at about 200,000 feet because Neil Armstrong did that in the X-15, right?
He did, yeah. And he had trouble controlling his craft. Yeah, I mean, that makes sense that they would use something that they think would approximate to the surface of the moon to create a life-size version of the Sea of Tranquility.
Mm-hmm.
The Geological Survey laid it out, and then they blew all the craters. I mean, you've seen the film of it. It's very straightforward. But it's obviously at Cinder Lake. It's obviously the Sea of Tranquility, as far as they could get it. So they could practice there. That makes sense.
Yeah, but you see, if the photographs are put together from all of their practice photographs, and it was all done at Flagstaff, then everything you see in the photographs is from Flagstaff. I'm quite sure they used the other locations for various other aspects of the program. I'm sure that Cannon Air Force Base, because it is not mentioned anywhere.
No, that's a good point.
So if you're going to do something on the absolute secret, if you're going to sit down and discuss something with the military, with NASA, with the president, anything else, it's a very central location to fly in from east to west and from Houston and everything else. It would be a good thing to go in there, do the design, maybe bring some equipment in and show how it's going to be laid out so people have an aspect of how they're going to simulate it.
That makes sense.
I was going to say fake it, but let's say simulate.
Yeah.
Right. And then all of that is being set up at Flagstaff because the surveys are done, the cue cards are done, the photographs are done. And of course, the photographs and the cue cards match. And that's all done in practice.
Yeah, of course it is. Yeah.
So that's what you see. If they showed us all the practice photographs, we'd know that they would be different. But all you see is the final version. And of course, Neil Armstrong's suit sitting in the museum is not ready for space flight at any god-given time. I mean, the zipper's this far short of doing up at the back.
Yes.
It doesn't have the inner liner that Phil Plait and all those guys claim the pressure suit inside is not even there on display. All of that stuff. The helmet connects to the outer suit, the white suit. And if there's a pressure suit, it wouldn't connect to that, even if the other part is missing. The helmet would have to connect and seal to the pressure suit, not the white suit.
No. I mean, that white suit was purely a sort of superficial dressing to make it look good and maybe to reflect a bit of sunlight, but that's about all it did. But all these stories that we keep hearing about NASA, it's like they wrote the film script to get the result. The final edit, the director's cut of NASA is what we've been shown because they had to get it right. They had to show American astronauts landing on the lunar surface. Mm-hmm. How they did it is really irrelevant.
The one talk that was, and I forget the name of the man that was at the British Interplanetary Society, he was talking about the Gemini program, and he was talking about them in the simulators, how they practiced in the simulators for the docking, undocking of the thing. And they actually had that in a hangar, hanging off of cables with electric motors, and they brought them in and out, and they could rotate them around, this back and forth, rotate them around and bring them in and out. And they had the controls in there are operating the electric motors to control them. That's for the Gemini program. I think they were just using the same hangar and the same stuff for the Apollo, and they filmed it, and those films are sitting in that McDonald's thing there at Menlo.
That's why they don't dare show the practice films, because it will show all the fakery that went on, the fraud that was put together to create the Apollo moon landing story.
Right, because they're going to look exactly the same as the final version that they took in the hangar for the docking, undocking sequences. And you can see when it's so-called coming up from the lunar surface, and then it goes jerk, jerk, jerk. Well, that's an electric motor turning on and off. That's not retro rockets turning it, because even when they shut off, they continue to turn, Even James Bond Moonraker, when they started turned the gravity on and off, right? They put on the rockets and that started to turn the space station, but it continued to turn. It didn't just stop again after they shut them off. They did it better in the movies. We need to go after NASA for these missing parts of the story. The parts of the story that are missing has all the preparation.
That's why it's missing.
Yeah, huge parts of the preparation of the story. It's only what we were presented to the media. But it was happening, the preparation was happening every day in many locations. All of that's missing. All the documentation, all the photographs, videos, the camera developments, everything else should be much more detailed.
So come on, NASA, show us those practice photographs. You got nothing to hide, have you? You landed humans on the moon. So let's see how you did it. We'd like to know what practice you did. We'd like to know how you overcame the problems that we know exist, and you probably know exist anyway. And you're now going to return to the moon with the Artemis program? Oh, pity about your launch pad. You forgot the flame deflector, didn't you? You didn't put anything underneath the rocket and it destroyed the launch pad.
The descent stage on the moon would be just as messed up, wouldn't it?
Yeah, it would.
I mean, imagine coming off of that and the blast is coming back and all of a sudden it's going to puncture through that, 3 layers of foil thickness of the shell? Come on.
As it lands, it's still putting out quite a lot of thrust. And you get all these NASA proponents saying, oh, it's not very much thrust because it's such a wide rocket skirt, 1,000 square inches of rocket, 3 pounds per square inch of thrust. That's quite a lot, actually. You try doing that. It's more than a bicycle pump can do. So it would start disturbing the surface and then some of it would bounce up.
The thing is the hypergolic fuel has an expansion rate of 3 times the speed of sound, 12,500 miles an hour it's expanding at. And that's what it's pushing out. That's the speed it's pushing out. And they can say, oh, well, it only has this much per square, whatever. Bullshit. It's going to punch a hole in the ground.
Of course it's going to punch a hole in the ground. What was in the hole? Lunar surface material. Where's it gone? Oh, because it's a vacuum, we're told, it just disappears. No, it doesn't.
I figured that they took the fuel tanks, those very small fuel tanks, way too small. I mean, they're only a quarter of the size of what they need, and just filled them with steam. And of course, that's where you had the panel, and we've shown that before, where it's actually the steam controls inside on the panel.
That was a very good find, steam control.
Yeah, I still have the images of that part of the panel. And that's what you're seeing on the ground. And of course, the steam's going to dissipate very rapidly.
Especially in a vacuum, don't forget.
Oh, yeah, but not in a vacuum. It's going to dissipate very rapidly.
Yeah, of course it is.
Okay, and it's going to look like it's doing something. And the little jets they had, they're shooting across the ground. They're not shooting down. Somebody described it as somebody's got like a big fire hose or something pushing steam out, and it's just shooting it back and forth like this underneath the craft. You're on a movie set and they need to have steam look like the exhaust is shooting across on the ground, right? So they got a guy with a steam hose pushing it out there, right? And we had 2 or 3 guys maybe doing that. I mean, it's no different. They're making a movie.
Yeah, they're making a movie.
If you look at NASA and you see the amount of equipment that they had to have, you imagine the lab that they would have to have had to deal with. We showed in the last video all of those reels, thousands of them.
Yeah, thousands. That video, number 45, which showed the missing reels, I thought it was one of the best that Robert has done. Excellent description.
Oh, absolutely excellent. All of the stuff, when you start to think about it, look at the photo lab they'd have to have just for the Hasselblad cameras. It's 60 guys with cameras, 6 weeks of training. If they used 2 magazines a day for 60 guys, you got 1,800 magazines right there. Then they claim that gave them cameras and they took them home to practice at home with and everything else. Somebody's developing all those. Then you got the DAC films and the 16 millimeters recorded from the TV cameras through all their practices. They had one hell of a photo lab there.
Yeah, it would be. So let's see them, NASA, 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 NASA.